Hello everyone, welcome to Akshara IIT Foundation. This is Srinivas from Maths faculty. Let us go to the today's class. Today we are in permutation and combinations, fourth synopsis. So let us take the important formulas related to this topic. Yeah, first one, if the number of ways in m plus n things can be divided into two different groups. Number of ways. Yeah, number of ways in which m plus n things can be divided. M plus n things can be divided into two groups or two different groups. Yeah, two groups, and that too m and n things respectively. M and n things respectively will be formula m plus 1 factorial by m factorial into n factorial. So there are m plus n things. We are going to divide these m plus n things into two groups as m and n respectively. So total number of groups m plus n factorial by separate groups now, two different separate groups now. So m factorial into n factorial. So this is one of the important formula. Next one, the number of ways in 2n things. So previously m plus n things are going to be divided into two groups. Now 2n things can be divided into two equal groups. Here two different groups actually. There are two different groups. Now 2n things converted or 2n things are separated into two equal groups of n things each. That means we have to make n things in each group, like two equal groups we need to make it. Now here how many groups are there? Total number of things are number of ways for 2n things. To make them into can be divided into two equal groups this time. So first one is for different groups and this is for two equal groups. That is nothing but 2n. Total number of things are 2n. So 2n factorial by n factorial into n factorial and with 2 factorial. These two also are dividing. Okay, na? So n factorial into n factorial. Or 2 factorial into n factorial square also we can write. Okay. Next, third one, the number of ways which can be 2n things. Again 2n things can be divided into among two persons equally. So previously two equal groups. Now here we are dividing the 2n things into two persons equally. So same formula, number of ways of 2n things divided into two equal groups. Now the same thing for two persons equally. So 2 persons equally is 2n factorial by n factorial into n factorial. That's it. There is no 2 factorial is here. Okay, na? Next, the fourth one, the number of ways in which n1 plus n2 plus and so on nk, that means k things. Here m plus n things, there 1 to n things can be divided into k different groups. So same format, k different groups. Different groups, how we are writing here? M plus n divided into two different groups like m and n. Here m factorial by n factorial. M plus n whole factorial by m factorial into n factorial. Same way, if you are taking things like n1, n2 and so on nk groups or nk things, that is nothing but n things are divided into k groups. That means 1, 2, 3 up to k terms are there, no? K groups. That is nothing but n1 plus n2 plus and so on plus nk factorial by, separately we are writing different groups, no? N factorial into n1 factorial into n2 factorial into n3 factorial and so on nk factorial. two different groups. Whenever we are taking the two different groups, m factorial into n factorial, same way, n1, n2, n3 up to nk. There are k terms now, so k different factorials we are going to dividing like this. Okay, next one, the total number of combinations, next format here. So once check it here, m plus n groups we are dividing into two different groups is m plus n factorial by n factorial into n factorial. Now 2n things we are dividing into two equal groups. Equal groups means 2n factorial by 2 factorial into n factorial into n factorial. So, but the same question is asking for two different persons. If you divided the groups into two different persons, format like 2n factorial by n factorial into n factorial. Same things. 1 to n groups are there. These 1 to n groups are divided into two different groups. Two different groups we are taking as n1 plus n2 and so on plus nk whole factorial by n factorial into n1 factorial into n2 factorial into and so on nk factorial. Okay, na? Now coming to the total number of combinations now. The total number of combinations of p plus 1 into q plus 1 of p plus q things taken any number at a time includes in case in which nothing will be selected. Okay, let us see the based on the combinations. Yeah, if you take the combinations, if you take p plus q things differently, then the combinations, number of combinations for p plus q things will be p plus 1 into q plus 1 ways. P plus 1 into q plus 1. Same way, if you take p plus q things are selected as one or more than one. Here nothing going to be selected here. Here first one is for p plus q things we are not selecting any particular thing, but how we are arranging them into how we are writing the combinations as p plus 1 into q plus 1 ways, but in the same p plus q things are selecting as one or more than one at a time. One or more than one. Here we are going to write it as one or more than one at a time. One or more than one at a time can be written in the format of p plus 1 into q plus 1 minus 1. Now, the third important formula, the total number of combination of n different things. For writing the, if you take n different things, how we are writing the total number of combinations is just for 2 power n. Okay, na? Same n different things we are writing as or selecting one or more at a time is going to be written as 2 power n minus 1. Okay, so let us go to the exercise problems. So first the concept based questions. The first one is the number of ways in which a man can invite one or more of his friends. A man is going to invite n friends one or at a time. One or more at a time. See here, the total number of combination of n different things, one or more at a time is 2 power n minus 1. Am I right? Here a person is going to invite 8 friends. 8 people he is going to invite at a time. One or more than one people is by using the formula 2 power n minus 1, where here n is nothing but n different things or n different people. Here how many people we are going to invite? 8 people. So 2 power 8 minus 1. What is the value of 2 power 8? 256. 256 minus 1 will be 254. Okay, na? So the number of ways a man can invite one or more at a time for the 8 people. Okay, so that is 255. 256 minus 1 is 255. Now the second question that is given, a man has 4 friends, so we can take it as 4 different friends or 4 different things. So then the number of ways can he invite one or more. Whenever you observe that number of ways is invite them is directly you can use the formula 2 power n, But whenever you see the sentence like 1 or more, you should use the formula for 2 power n minus 1. Here there are 4 friends, so 2 power 4 minus 1. So what is the value of 2 power 4? 16. 16 minus 1 is nothing but 15. Okay, na? So let us move on to the question number 3. Question number 3, that is the number of ways of selection. Again, the number of ways of selection of 1 or more than 1 out of 7 given things. That means 7 different people, like n different people. So same formula, this is also, it is going to be written as 2 power n minus 1. That is equals to 2 power 7 minus 1. So 2 power 7 value is nothing but 128. Minus 1 is nothing but 127. Okay, the answer will be 127. Now let us go to the problem number 4. There are 10 lamps. How many lamps are there? 10 lamps. So in a hall, each of them can be switched on independently. Each of them can be switched on independently. The number of ways in which the hall can be illuminated is same way. Here 10 lamps are there, nothing but how n different things are there, same way 10 different lamps will be there. The 10 different will be there can be each of them, that means 1 or more than 1 independently switched on them. So same formula we are going to write it as, so 2 power 10 minus 1. So 2 power 10 value 1024 minus 1 is nothing but 1023. Therefore the number of ways is 1023. Okay, no? So let us move on to the problem number 5. Okay, right. So in a crossword puzzle, 25 words are to be guessed, of which 6 words have each an alternative solution. So 6 words are having the each of an alternative solution also. The number of possible solutions. So how many are there actually? There are 25 words. Among the 25, 6 out of them having alternative solutions. So only 6 of them alternative solutions. So 25 minus 6, remaining 19 are having only one solution. There is no alternative solution for the remaining 19. So 6 questions having the alternative solutions. Now then the number of possible solutions are there. So how many number of possible solutions are there? For the possibility of solutions, so whether the solution is true or false. Okay, 2 solutions will be there now. So this is also same under consideration of the same formula, 2 power n. Okay, so how many are there? How many of them having alternate solutions? Alternate solutions means, so 2 different solutions we can take. So 2 power 6. 2 power 6 is nothing but 64. Yeah, 2 power 5 value is 32. Nothing but 2 power 6 is 64. These are the number of possible solutions. Okay. Now let us move on to the question number 6. The number of products that can be formed with 10 prime numbers. So we need to form some products by using the prime numbers. 10 prime numbers are taken, 2 or more at a time. So 1 or more at a time we are going to write as 2 power n minus 1. So 2 or more at a time, how we are going to write it as? So let us take the prime numbers like A, B, C, D and so on. Yeah, for 10 solutions, if you are wanted to write like, let the prime numbers, we don't know what are the primes actually, so I am taking represented with the letters A, B, C, D like that. Like that 10 prime numbers we are taking. So for arranging them combinations like first one as 10C1, 10C0 plus 10C1 plus 10C2 and so on. Up to 10 different numbers, 10 different prime numbers. Okay, na? So, but while you understand the question like it is 2 or more, that means first 2 we are neglecting, 2 or more. That means 10C0 and 10C1 we are not considering. 10C2 onwards up to 10C10. Okay. Now how we are going to write it as? Yeah, 10C0 to 10C0 to 10C1, 10C2 and so on, 10C10. So 10C0 and 10C1 both are represented the same values like 1, 10C1 value 10. So according to the combinations, NC0 value, NCN value equal, they are represented with the number 1. So NC1 value n, NC2 is nothing but n into n minus 1 by 2 into 1 we are going to write like this, combinations. Okay. Now same way here, for writing the remaining, so I am going to write from first to last all of the numbers, but in the question it is given that 2 or more than 2, that means first 2 we are going to subtract. So 10C1, 10C0 we need to subtract, then it will give that 2 or more solutions. Okay, so for a combination of these, we are going to write first 10 solutions, we are going to write as 2 power 10 minus 10C1 value is nothing but 10, 10C0 value is 1. So minus 10 minus 1 is nothing but minus 11, and 2 power 10 is nothing but 1024. Okay, 1024 minus 11 and 1013. 1013 is our required solution. Or you can write it as 2 power 10 minus 1 according to the following options. The options are given here. This is going to be written as 2 power 10 minus 11. In the question, the option is given like this. Okay, na? So first 10 numbers we are going to arrange in a combinations of 2 power 10. But among them it is given the condition like 2 or more than combinations. So 10C0 and 10C1 we are neglecting. So that's why I am removing both of them. So will be the answer as 2 power 10 minus 11. Okay. So let us move on to the problem number 7. Yeah, the 7th one. A question paper contains 6 questions. Each have alternative. So all 6 questions having the alternative it seems. Then the number of ways that an examines can answer one or more questions. Yeah, number of ways examines can answer one or more questions like. So if you are answer a question like that, question can be the correct solution or incorrect solution, 2 different ways, or it cannot be attempted also, 3 different ways will be there. So here how many solutions, how many questions are there? 6 questions. The 6 questions can be attempted by an examiner or examine by in 3 different ways. So he can attempt the question in a correct method, or he can attempt the question in a wrong way. He cannot attempt at all. So 3 situations for 6 questions. So each one having the 3 situations or 3 solutions and different ways. So 3 into 3 into 3 up to 6 times. So 3 power 6. 3 power 6. 3 3 is 9. 3 3 is 9. 9. So 9 cube 729. Okay, no? So number of ways. Here also again, up to here we have just written the combinations of 6 different questions. But here last at the point it is given 1 or more questions. Whenever we are writing that 1 or more condition, we need to subtract minus 1. Am I right? According to the previous formulas. Yeah, whenever P plus Q things are arranging in a manner that 1 or more than 1 at a time, we are writing a format like P plus 1 into Q plus 1 minus 1. Okay, same way here also the 6 different questions can be attempted in a 6 different ways, means 3 different ways in each will be 729, but at the end of the question it is given that 1 or more at a time is nothing but minus 1. So 729 minus 1 will be 728. Okay. Now, eighth question. The number of ways in which one or more balls can be selected out of 10 white, 9 green, and 7 blue balls. Okay. The number of ways, one or more balls. Here also given the condition like one or more balls. Whenever you see that one or more, here three different combinations are given, that is 10 white color balls, 10 white and 9 green color and 7 blue color. 9 green, 7 blue. That means P and Q different number of things we are going to arrange like P plus 1 into Q plus 1. PQR if you take P plus 1 into Q plus 1 into R plus 1. So whenever you see the sentence like one or more, we are going to arrange it as 10 minus 1 into 9 minus 1 into 10 plus 1 into 9 plus 1 into 7 plus 1 minus 1 combinations. So 10 plus 1 is nothing but 11 and 9 plus 1 10, here 8. So 10 into 11 into 8. So 880 minus 1, 879. Okay, now? The answer will be 879. Here three different things will be there. Each thing, that means first thing having total 10, second type of thing having 9 combinations, and third one 7. So these are going to be arranged in a manner of one or more. It is being like that P plus 1 into Q plus 1 into R plus 1 minus 1 combinations. So this is our required answer. Let us move on to the problem number 9. Yeah, right. So problem number 8, until then concept based questions are completed. Let us move on to the exercise based problems. The first question in exercise 1, that is given that the number of ways in which 900 can be solved as a product of two factors. Product of two factors of number of ways. So in our previous classes, that is nothing but number system, we have discussed that if a number is written in the form of product of two factors in a number of ways, a number can be expressed as product of two factors. For example, if you take the 24 we can write it as 1 into 24 is a one way, 2 into 12, 3 into 8, like that some different type of ways will be there. So here we no need to use any formula, directly we can identify the prime factors of a number. Okay, na? Yeah, that is prime factor. Here 900 is given. So let us try to find out the prime factor of this number. So here 5 table, 5 ones are 5, 8's 40, 180. So 5 table again, 5 threes are 15, 5 6 are 30, 36. 2 table 18 times, 2 table 9 times, 3 table 3 times, and 3 table 1 time. So while you are going to, there are 3 different prime numbers, that is nothing but 2 square into 3 square into 2 square, 5 square into 3 square into 2 square. Therefore total number of factors is equals to 2 plus 1 into 2 plus 1 into 2 plus 1, nothing but 3 into 3, 27. Then the number of ways is equals to, whenever you have the odd number here, we are going to write as that odd number plus 1 by 2. Whenever you are having that even number, directly divided by 2, the number of ways will come. So the number of ways is 27 plus 1 by 2, nothing but 28 by 2, so will be 14 ways. Okay, na? So answer will be 14 different ways. Let us move on to the question number 2. Okay, the second question, in a village there are 600 families. In a village there are 600 families, 100 have no children. 600 families, out of them 100 having no children and 200 have only boys. This is for no child. Okay, 200 having only boys and 200 have only girls, another 200 having only girls. So total number of families are 600, out of them 100 having no children, 200 having only boys, and 200 having only the girls. Okay, the number of families that have boys and girls, the combination. So what are the remaining? So remaining is 100. They are having only boys and girls together. Okay, let us move on to the question number 3. The third one, the number of ways, so the number of integers between 1 and 567. Number of integers between 1 and 567, between numbers, which are divisible by either 3 or 5 or 7. So between 1 to 567, total number of integers we need to find. For example, between A and B, how many number of integers will be? For that formula, B minus A minus 1. Okay, na? B must be the greater than A. So same situation we are going to retrace. 567 minus 1 is nothing but 565. 565 integers will be there. Among them, which are divisible by 3, which are divisible by 5, or which are divisible by 7 also. Okay, let us see that. Out of 565, the number of integers divisible by 3. Number of integers divisible by 3. Let us divide the integers with 3. So 3 ones are 3, 26, 3 8s are 24. Again 3 8s are 24, one remainder. Let us leave about this. There are 188 numbers which are divisible by 3. Okay, na? So divisible by 3 are 188. Okay. Now divisible by 5. Let us take the 5 table. So 565, 5 ones are 5. Again 5 ones are 5. 5 threes are 15. So there are 113. So divisible by 5. Okay, na? Next, divisible by 7. Same number, let us try to divide with 7. So 7 8s are 56. That means 80s are 560. So 80 of them are divisible by 7. Okay, now the question comes to the question. Yeah, 3 or 5 or 7. Now we have only divisible by 3, divisible by 5, divisible by 7. For example, out of them, few of them having a combinations. Okay, na? Combinations like some of the numbers in between them are divisible by both 3 and 5 also. 3 and 5 means 15, right? So that is also we need to find. Some of them should be divisible by 3 and 5, 3 and 7, 5 and 7 combination also we need to take. Let us try that one. So 3 and 5 nothing but 15 combination, 15 with 565. So 15 table 4 times 60, so 3 times are 45. 3 times are 45. Here 1 remainder here 5. So I think 7 times 7 tens 70 plus 35, 105. Yes, 7 times 105. So let us forget about the remainder. So there are 37 are there. The combination of 3 and 5. Now let us take that the combinations A. Let us take A with divisible by 3. B is divisible by 5. C is divisible by 7. So combination means A and B together. So this is A intersection B. A and B. So divisible by this is number of integers divisible by 7. N of C. This is N of A intersection B we got. So first one we can take N of A. Second one we can take N of B. n of b, third one n of c, and the fourth one n of a intersection b. That is the combination of both 3 and 5. Let us take 3 and 7. 3 and 7 combination. Okay, so 3 and 5 combination, n of a intersection b, we are getting 37. Now 3 and 7 combination. So 3 and 7, 3 7s 21, right? So let us try to divide with 21 with 565. So 21 2s are 42. Here 14 will be 145. So I think 7 times. 7 times are getting more. So 147 is getting. So 6 times. 6 times something remainder will be there. So 126. So we are getting the remainder, but remainder we are neglecting now. So n of a intersection b is given, a intersection c. N of a intersection c is equals to 26. Now 5 and 7 combination. Okay, 5 and 7 combination. 5 7 is 35. So 35 with 565. 35. So 35 ones are 35. Here 21 will be. So I think nearly 6 times 630 is 180. 180 plus 6 5s are 30. 210. So 6 times. So this is B intersection C. B intersection C is 16. So n of A, n of B, n of C, n of A intersection B, A intersection C, and B intersection C. Next, last combination, 3 of them together, divisible rules. That means they are divisible by both all 3, 5, 7 together. So 3, 5, 7. So they are all prime numbers. 3 into 5 into 7 combination. That is 3 5s are 15. 15 into 7, 105. Okay, now? So let us try to divide with 105. So I am just take the place here to erase the place. Yeah, 105. That 105 with 565. So 5 times exactly. So remainder will be there. So nothing but 525 will come. So remainder we are neglecting. This is the combination of n of A intersection A, B, C all together. Now you need to remember the formula, that is n of A union B union C. That is nothing but the number which is divisible by 3 or 5 or 7. Here union indicates or, intersection indicates and. The formula is n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of C intersection A plus n of A intersection B intersection C. Okay, n of A how much? N of A value 188. I am writing here 188. I am writing here 130. That is, sorry, remember. Yeah, 188. N of B is 113. N of A plus N of B plus N of C. N of C value 80. Next, N of A intersection B intersection C, that is 5. Now let us try to add all the positive numbers, then later subtract the negative numbers. Okay. Now 2 8s are 16, 1. So this is 18, 386. Now out of them combinations, A intersection B, B intersection C, and C intersection A. A intersection B value 37, 26, and 16. 37, 26, and last one 16. So 6 plus 6, 12 plus 9, 12 plus 7, 19 here 1. So 4, 4 plus 3, 7, 17 is. Let us try to subtract 79. So 16 minus 9 is 703. There are nothing but 307 integers will be divisible by 3 or, yeah, first option. 30 is given, try to change the option 307. So the number of integers between 1 to 566 divisible by 3 or 5 or 7 or 307. Okay, so let us move on to the next problem. That is, a basket contains 4 oranges, 5 apples, 6 mangoes. The problem number 6. The basket contains 4 oranges, 5 apples, and 6 mangoes. 4, 5, 6. Yeah, 6 mangoes. The number a person make a selected are 1 or more. So the person is selected all at a time is nothing but p plus 1 into q plus 1 into r plus 1. But here the condition is given 1 or more. That is the combination of 4 plus 1 into 5 plus 1 into 6 plus 1 minus 1. 4 plus 1 5, 5 plus 1 6, 6 plus 1 7 minus 1. So 4 6 are 30, 30 into 7, 210 minus 1, 209. Okay, now? Let us go to the problem number 7. The 7th one, that is given, the how many different sums can be formed with the following coins a rupees, following coins as a rupee, 50 pice and 25 pice coins, 10 pice and 5 pice. Total how many number of coins are there? So 1 rupee, one different coin, 50 pice coin, 25 pice coin, 10 pice and 5 pice. Total 5 different coins. 5 different coins to be formed as a different number of sums. That is 2 power n minus 1, because each coin having tail or head, 2 different ways. No, their sum we are going to add it. Yeah, 2 power n minus 1, it is nothing but 2 power 5. There are 5 different coins. 32 minus 1 is 31 ways. Okay. Now question number 8, that is the sum of divisors. Sum of divisors of 2 power 5 into 3 power 4 into 5 square. Sum of divisors of that means the number is already given in the product of its prime factors. That is nothing but 2 power 5 into 3 power 4 into 5 square. 3 power 4 into 5 square. As a number system, we are having a format like this. So yeah, the formula like let me write the formula like n1 power p1. That means if a composite number is expressed as a product of primes like n1 p1, let us take p1 p2 p3 as a primes. So p1 as a prime, p2 as a prime, p3 as a prime, and so on like this. And p1 is repeated n1 times, n1, n2, n3 like this, the sum of factors formula. So p1 power n1 plus 1 minus 1 by p1 minus 1. Same way, p2 power n2 plus 1 minus 1 by p2 minus 1. Like that we are having the factors. That is, that many times we need to multiply, depends on the number of factors, different primes. So here this is 2 power 5 plus 1 minus 1 by 2 minus 1 into next prime number 3, 3 power 4 is given. So 4 plus 1 minus 1 by 3 minus 1. And next one 5, 5 power 2 plus 1 minus 1 by 5 minus 1. So 2 power 5 plus 1 means 6, 2 power 6 value is 64. 64 minus 1 is 63, 63 by 1. 2 minus 1 value 1. Next 3 power 5. 3 power 5 value is 243 minus 1, 242 by 2. Am I right? So 3 power 4 81, 3 power 4 81 into 3, 243. 243 minus 1 is 242. Denominator is 3 minus 1 2. Now 5 cube value 125 minus 1, 124 by 4. Okay, 4 table here 31 times. 2 table here 121 times. So 63 into 121 into 31 will be our required answer. 63, 121 and 31. 63, 121 into 31. This is the sum of all the numbers. But the answer is given in the product of its primes. So let us write 63 is 3 into 7. Am I right? 3 into 3, 9. 9 sevens are 63. Now 121 is a square of 11. 11 is a prime number, 11 into 11. Now 31 is also a prime number. So while you are expressing like this, 3 square into 7 power 1 into 11 square into 31. So this is our required option, nothing but second one. 3 square, 7 power 1, 11 square into 31. Okay. Now let us move on to the question number 9. Yeah, the ninth question is given that the sum of factors of 9 factorial which are odd and are in the form of 3m plus 2 where m is a natural number. So we need to take 9 factorial, sum of the factors of 9 factorial. So 9 factorial value we need to get it, 9 factorial is nothing but 9 into 8 into 7 into 6 into like that. So when you multiply that, we will get a composite number, no? That composite number, sum of the factors. Sum of the factors, how we are writing this? Same way, but here asking that which are odd and are in the form of 3m plus 2. Among them, we need to find only the odd numbers. Odd numbers are in the form of 3m plus 2 format. So where m is a natural number. Okay, so let us try to write the 9 factorial. 9 factorial I can write it as 9 into 8 into 7, 6, 5, 4, 3, 2, 1. So 1 we can neglect. Now 9 can be written as 3 square. 8 can be written as 2 cube. 7 is already a prime number. 6 can be written as 2 into 3. 5 prime number. 4 2 square. 3 into 2. So let us write into the single like 3 power. Here 2 will be, here 1 3, here 1 3. So 3 power 4. Now 2 powers, 2 cube, 2 power 4, 2 power 5, 2 power 7. And 5 power 1 and 7 power 1. So 9 factorial we are going to express as product of its primes, but among them we should take only the odd numbers. So sum of all numbers we can directly take in as p1 power n1 plus 1 minus 1 by p1 minus 1, that formula. Means previous problem how we are discussed like this, same formula we can go through it. But you are asking about the numbers which are having a primes, their sum only we should find. So only that means that are the primes with odd numbers, not even numbers. So prime with odd numbers here 5 and 7 will be there. Okay, na? So odd factors are in the form of 3m plus 2. 3m plus 2 format. Here 3 also odd number, but 3 is in the form of 3m only. Okay, na? So 3m plus 2 format is 5. 3 into m plus, if you take 1, 3 ones are 3, 3 plus 2, 7. Sorry, 3 plus 2, 5. Same format. So 3 2s are 6, 6 plus 1, 7. So 3m plus 2 or 3m plus 1 format we are getting 5 and 7. But here, yeah, so neither. Here 2 and 3, if you take that 2 and 3 are not in the form of 3m plus 2. So 3m plus 2 having a format of 5 and 7 only. So the factors of maybe 5 and 7 and 35. 35 also will come now. 5, 7, 35 also will come. So with just 5 and 35 are the sum of because 7 is not getting as 3m plus 2 format, this is coming as 3m plus 1 format. Okay, now let us check that 5. 5 coming as 3m plus 2 format to 37 also coming as 3m plus 2 format to 3 11s are 33, 33 plus 2 35. So 5 and 35 having a 3m plus 2 format to, then you are asking about their sum. 3 plus 35 is nothing but 40. This is our required answer. Okay now? Yeah, please look into it. Let us go on to the problem number 10. That is, if R, S, T are the prime numbers and P, Q are the positive integers such that LCM of P and Q are given, are in the format of R square T power 4 S square. R square T power 4 S square. Okay, this format will be, then the number of ordered pairs of P, Q. Number of ordered pairs of P and Q. Yeah, let us take that. But we don't know the prime numbers also. If we know the prime number, we can express as product of its factors and in exponential form, but here not given any prime numbers. So let us check that. So 2, 4 and 2 as a powers. So S we can write it as S square, we can write it as S power 0, S power 1 and S power 2. Am I right? S square we can write it as S power 0, S power 1, S square. Okay, 3 power 1, 3 power 2 like that. So R square also R power 0, R power 1, R power 2. But T power 4 we are writing as T power 0, T power 1, T power 2, T power 3, T power 4. Now while you are writing this one, S square we are expressing in 3 different ways. S0 into S1 into S2. Okay, that is nothing but 2 into 3 minus 1 combination. 2 into 3 minus 1 combination. So this is also 2 into 3 minus 1 combination. Now what about this 1, 2, 3, 4, 5 times? So 2 into 5 minus 1 combinations. So 2, 3 are 6, 6 minus 1 is 5. This is also 5 and it is last one is 9. So 5 into 9 combinations, that is nothing but 25 into 9, that is 225. 25 times 250. So 125 we can subtract 225. Okay, now? Now let us see the 11th question, that is, a person writes letters to 5 friends and addresses the corresponding envelopes. The number of ways can the letters be placed in the envelopes so that all letters are to the wrong envelopes. That means the wrong address we need to keep it in the letters. That means one letter has to go with the correct address, but that letter we are keeping in another envelope. That means wrong envelope. So the letters of combination with wrong envelopes. So here 5 letters can be arranging in 5 different ways. That is nothing but 5 factorial. Am I right? So 5 letters can be arranged in 5 different covers in 5 factorial ways, and all must be wrong, right? All envelopes will be wrong. Yeah, for this having a formula like, so first the letters can be arranged in 5 factorial ways. 5 factorial ways into, first one can be arranged in 1 by 1 factorial. First one can be arranged in 1 minus. First one can be arranged in 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial, like that. Okay, no? So this is the wrong way of arrangement of 5 letters in 5 envelopes, means different number of envelopes. Okay, let us check this one. 1 minus 1 by 1 factorial. 1 factorial means 1 only. 1 minus 1 by 1, sorry, plus 1 by 2 factorial means 1 by 2 itself, minus 3 factorial means 1 by 3 into 2, 6, 1 by 6, 4 factorial value 24, 5 factorial value 120. So plus 1 minus 1 can be cancelled. So remaining LCM we can take it as 120 as a LCM. That is equal to 5 factorial by LCM is 120. Now this one, 2 table 120 60 times. 60 into numerator 60. So 6 table 120 20 times here minus 20. Now plus 24 table 125 times 5 minus 120 table 120 only one time. So 5 factorial value is nothing but 120 only. So numerator 120, denominator 120 can be cancelled. Now 60 minus 20, 40, 40 plus 5, 45, 45 minus 1, 40. So they can be arranged in wrong envelopes or nothing but 44 ways. So this formula you need to remember. Okay, no? Right. Yeah, that's it for today, children. Thank you, one and all. Have a nice day.